Avogadro's law of gas volume states that equal volumes of different gases at the same temperature and pressure have equal numbers of particles. Right, so by this we mean that if they've got the same volume, two gases, so imagine we had two gas jars like this. One filled with oxygen, excuse me, the other with chlorine. Right, let's say we had 2 liters of oxygen, 2 liters, should I say decimeters cubed. Let's use decimeters cubed because so you have 2 decimeters cubed of each one. You will have equal number of moles. Right, so the number of particles the same, equal in both samples. Right? And this means that they have the same number of moles. Now it turns out that we know, so it doesn't actually matter on what gas, right? You see, it doesn't matter on the gas. It's just the way the gases behave, just because they're little spheres that go around bumping into each other. So it doesn't make much odds on what the actual molecule is. They'll have different densities, of course, and different properties, but their volume just depends on the number of moles. Of course, that's only true if the temperature and pressure is the same. And it actually turns out that 1 mole of any gas at standard temperature and pressure, that's what that stands for, standard temperature and pressure, occupies or has a volume of 24 decimeters cubed. Right, now we call this the molar gas volume. Right, so that Vm is called the molar gas volume. Right, and it is 24 decimeters cubed at standard temperature and pressure, of course, because it varies with standard temperature and pressure. Now this tells us that 1 mole occupies a volume of 24 decimeters cubed. So this is actually in decimeters cubed per mole. Right, so Vm, so this should be per mole. Right, so we can write an equation actually. It's Vm equals V over N, where Vm is a molar gas volume, we've said decimeters cubed per mole. V is the volume of gas course, in decimeters cubed. And N is the number of moles. Right, now this is an important equation that you have to be able to use. Right? Vm is always 24 decimeters cubed per mole. Right? This is our molar gas volume. It's our constant. So you're going to be expected to use this equation. Right? If you like it in triangles. Right? So you have to be able to use this equation. Now, let's do an example. So what volume would 0.5 moles of nitrogen occupy? Right? So we're looking at this equation. What it's asking us is for V, the volume of the sample. Yeah? So now V is going to be the molar volume multiplied by the number of moles. The number of moles is 0.5 moles. This is N. Right? Vm is 24. So we're going to go 24 times 0.5 equals 12 decimeters cubed. Very simple. Right? We could also be asked to use the equation to calculate the number of moles in a volume. Okay, so you could be asked how many moles of CO2 are there in let's say 12 decimeters cubed of 12 decimeters cubed. There you go. In 12 decimeters cubed. Question mark. Right, so this time we want N. Right, so that's going to be the volume over the molar volume. Right, so we have V. Yes, of course, we've got 12 decimeters cubed. Right, the molar volume is always 24. And I think you'll find that turns out to be 0.5 moles. I should have expected that, because here the answer we got was 12 decimeters cubed for half a mole, and it doesn't actually matter on what the gas is. Here, carbon dioxide, half a mole occupies 12 decimeters cubed, as does nitrogen. There's the molar gas volume. Thank you very much.